systems of inequalities. I think systems of inequalities are fascinating because part of the kind of application of them is about finding finding the best deal. And so you can create a system of inequalities from things like taxi cab fares or cell phone monthly plans or other sorts of data plans and monthly charges and things like that. And so kind of the reasoning behind this is finding the optimum, or finding when one choice is better than another choice. We're not going to go into that part of it a whole lot, especially not today. But it's kind of cool to know that that's where this leads to. So systems of inequalities is a combination of two things that we've done. One is graphing the linear equalities, and two is a system of equations. But with a system of inequalities, there's infinite solutions. There's not just one solution, like with a system of equations. And so when we solve these, the only way to really solve them, or to represent your solution, is in a graph. So all you're doing is graphing and shading. Okay? So here's an example. A system of inequalities could be something like this. Y is greater than 1/2 x plus 7. Y is less than or equal to 2x minus 3. So what do? Well, we pretend that these just say equals. And we pretend that they're two separate problems. So basically, I just take the first one and I graph it. Let me use a ruler. So, make our axis over here. What form are these in? Slope intercept. So I look at my intercept. Right? 1, 2, 3, 4, 5, 6, 7. With a dot. I'm going to make 1, 2, 3, 4. And then I look at my slope. Oh, sorry, I meant to make that negative 1/2. Down 1 over 2. Down 1 over 2. Down 1 over 2. And we have a line. But as I'm making this line, I'm thinking, oh, wait a second. It doesn't say equals, does it? It says greater than. So this is the first time when I have to think about an inequality, and I realize that this line should be dashed. Dashed line. And then, this is where this is a little bit different than just graphing an inequality. What I do next is I figure out which side I would shade on. So let's plug in the point 0, 0. 0 is greater than 7. That's false, right?
Yep,
so we would shade this way, but all I usually do is I just put I make a little note to myself that I'm shading that way. And you'll see why I do that in a second. Okay. Second line, let's graph it in a different color. We'll graph this one in red. So I start out by going down 3 to 3, and then I go up 2 over 1, up 2 over 1, up 2 over 1, 2 over 1, something like that. This line, though, is solid. And then I figure out which side of this line to shade on. So is 0 less than negative 3? No, it's not. It's greater than. Or equal to no. So I shade on that side away from 0, 0. Now there's two ways of doing this next step, and I'm going to show you both. The first way is you just shade everything. Like I would just shade everything on this side of the line. I try to like do it in one direction, and then I shade everything on this side of this line, and I do it in the other direction. What do you think my answer is? What is the solution to this system of inequalities? Yeah.
Like that corner with both of the lines?
This corner is both of the lines. What were you going to say?
Same.
Same thing? What were you going to say? Same thing? Yeah, that's it. So it's where those two regions overlap. Instead of looking for the point where they meet, we're looking for the entire region of the graph where they overlap. So the other way of doing it is, instead of drawing all these lines, I've just drawn my little arrows to remind myself of which way to shade, and I just figure out where that would overlap.
Yeah.
So I can just say like, oh, I see that if I shade here and here, the overlap is there.
So what do you do for the actual answer?
And that's your answer. That's all
So
you do.
it's a graph and there's no like equation. We just like circle that area.
Yeah, now a lot of times what I might ask you to do is like circle the region of overlap, which technically is impossible because it goes on forever. But
like
we can circle the part of it that's on our graph, right? Which is like this. The interesting thing about this problem is this line would be included in our answer, but this line wouldn't, because this one's dashed and this one's solid. So if we were to pick a point that's right on this line, it would be true in both of these inequalities. If we picked a point right on this line, it would not be true in both of these inequalities. If we picked a point anywhere over here, it would be true in both of these inequalities. Now there's something else we could say. If I picked a point in this quadrant, it wouldn't be true in either inequality. Okay? But if I picked a point over here, it would be true only in this one. And if I picked a point over here, it would be true only in this one. So what we're looking for is which quadrant has solutions to both inequalities. Right? Any point over here would be true for both of these. Right? So if I picked a point like, I don't know, 15, 7, let's plug it in. So we'd have the first one, 7 is greater than negative 1/2 times 15 plus 7. So that would be 7 is greater than
30.
Well, 1/2, right? So negative 7.5 plus 7.
Oh, yeah.
7 is greater than negative 0.5. That's true. I plug that same point in here. 7 is less than or equal to 2 times 15 minus 3. So 7 is less than or equal to 30 minus 3, which is 27. And that's also true. If I've evaluated these correctly, which I think I have, we can see that this point, somewhere over here, is true in both inequalities. Okay? Now you don't have to do that to solve these, but I think it's really important to understand what we're saying. And what we're saying is that any point in this region is true in both inequalities. Any point over here is true for this one but not this one. Any point over here is true for this one but not this one. And any point over here is not true for either. And this is kind of what I meant by, like, if you're comparing cell phone plans, right? You could create a linear equation for most cell phone plans. It's usually like some amount of money per minute or per data that you use, plus some amount of just charge per month, right? So you could create a linear equation for that. And then you can compare, well, if I use this much data, right, which plan is cheaper? And you could say, well, I see that over in this region, this plan would be cheaper. If I'm using this much data, this plan would be cheaper. That sort of thing. So there's a lot of kind of applications of linear inequalities. All right, let's just do another example without all that extra explanation and talk. Even though I think that stuff is fascinating too. All right, what if I had something like this? Y is less than 5. Y is greater than 2x. All right. How do I graph y is less than 5? Straight line going horizontally.
But it's dashed.
It's dashed,
5.
and it's at y is equals 5, right? And which way would I shade? Let's plug in a point. 0, 0. Wait, how do I plug in 0, 0? There's no x here.
Would it just be that? Would it just be a solid line and anything on that line?
No, because x is.
Wait, so it's nowhere.
Well, let's think about it. The point 0, 0 has an x and a y, right? The x is 0 and the y is 0. So I actually can plug that in. I'm just not plugging in the x part. I'm only plugging in the y part. So if I plug in 0, 0, it would just say 0 is less than 5. That's true. Which, if you think about it, that kind of makes sense. Y is less than 5, so we're going to shade down to everything that's less than 5.
Yeah, that makes sense.
I mean, that kind of makes sense. Like, right here, y would be 1. So we'd have the point 0, 1. If I plug that in, 1 is less than 5. That's also true. Whatever my y coordinate is,
So
right?
So it's
When I
literally
plug
just
in a point,
everything below that.
I just plug in the y coordinate.
Okay, but does that mean it could be on any x as well? So it's anything below that.
So it could be like over here, right? Like, maybe this is the point 4, 3. If I plugged in the point 4, 3, I really am just plugging in 3. Because there is no x here to plug into. So there's only the y to plug into. So we've got 3 is less than 5, which is true. Right? This is x comma y. So I'm really only plugging in the y. There is no x in this equation.
Okay.
So I would shade down. And I'm going to use the second method that I described. So I'm just going to draw a little arrow here to remind me that I'm shading down. Then I'm going to graph this one. Slope-intercept form. So I go down 3. 1, 2, 3. Up 2 over 1. Up 2 over 1. Up 2 over 1. 2 over 1. Something like that. Also a dashed line. Dash, 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 dash. Okay? And which way do I shade that one? Y is greater than 2x minus 3, so if I plug in 0, 0, 0 is greater than negative 3. That's true. So I would shade this way. Now where would those overlap? We have 4 quadrants. 1, 2, 3, 4. Hold up the number of fingers of the quadrant that you think it would be in, of what I just named. So 1, 2, 3, or 4. Which one would it be in? Yeah, it would be in this one right here, right? Because this is coming down, and this is going up, So they would overlap right here. This is how I usually draw my overlaps. It's like abstract. And we can you guys tell me about the other quadrants? Like what would be true of any point in this quadrant?
The second equation?
This one would be true, right?
Yeah.
What would be true of any point in this quadrant?
Nothing.
Neither equation would be true.
Then the third quadrant, it would be the top.
Yeah, this one would be true here, but this one would be false. And this one is where they both are. I should have done my quadrants. Did you guys know, like, on a graph, how the quadrants are labeled?
Yeah, it's like one.
It's technically like 1, 2, 3, 4, right?
Yeah.
So that's something totally different. That's not what I was talking
Oh,
about.
okay.
But
Yeah, but the first time.
I was just saying, there's 4 parts to this, right?
Yeah.
So I called them quadrants. Yeah.
So the answer, do you put like the 4 quadrants or something?
No, your answer is just this.
Oh,
Your answer is showing which of those. I really shouldn't use the word quadrant because the 4 quadrants on a graph are really this, 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 and this. So, I don't know, like the 4 regions, right? We have 4 regions made by these 2 lines, right? And we're just showing which of those 4 regions do the solutions overlap. Questions? You guys think you can do this? Fist of 5, show me.